Why am I talking about PKS? Well, some of you may know this. Back in April, I did a 4-month stint in the Dublin office, actually working on the ODPKS team. Meant to give this upon returning in August. Unfortunately, timing didn't align until now. But now, hopefully, I want to share some of the learnings about PKS in general, Kubernetes, why both of them are really hot right now, and give a little bit of a insight into how PKS actually works. So we'll start by talking about what Kubernetes is, for those of you in the room who might not be as familiar with it, the benefits, the use cases, and then we'll talk about what PKS is, how it builds on top of Kubernetes to give you even more power. We'll then do an architecture deep dive of actually how PKS is working under the hood, because I think it's pretty cool. And then leave with some additional resources if you want to dive even deeper into the subject matter. So what is Kubernetes? Right, so Kubernetes is a container orchestrator built around Docker. So with Docker, you got the power of being able to create containers, have your applications running with all of its known dependencies and binaries in a really easy, quick, automatable fashion. But you needed to manage all of your Docker containers. You need to manage all of those images. You need to ensure that everything is running smoothly. And this is where Kubernetes came into play, right? With Kubernetes, you really get that container orchestration level. You no longer have to worry about managing your containers per se. You can let Kubernetes provide a simple, intuitive interface to do so. So how does Kubernetes actually work? So if you've ever stood up a Kubernetes cluster, there's sort of two main types of virtual machines. There's the master and the worker. So this is a highly simplified diagram. There's a lot of other components that you may care about, but we'll be talking about sort of the main things on each. So on your master nodes, you'll have all of the Kubernetes components that allow you to be scheduling your containers, be managing your containers, be doing that container orchestration level. We have the Kube API server, which will be what anytime you issue a command via via terminal, or you want to do something with your pods, will be hit. It's your entry point. It's your API server. We then have the scheduler, which is actually dealing with the scheduling of your container workloads. And then we have the controller manager, which deals a lot of times with like certificate generation and other things. And then we have numerous worker VMs. And this is where if you have an application per se that you want to be deployed in a container, your application will actually be running. So we have on your worker a kubelet, which is a process that's actually in communication with your Kube API server. And then we have your numerous pods, aka your containers, where your applications are actually running. So let's actually walk through a workflow of how you would go from an end user to actually deploying an application on Kubernetes. So you're this really cute icon right here, right? And you want to deploy an application on Kubernetes. You're going to issue a command via the command line, and we see here that it hits the Kube API server. And so you're telling the Kube API server, hey, I know that you're a cluster that exists here. I have a workload that I'd like scheduled on Kubernetes. The Kube API server will then, via the help of the scheduler, decide which worker to actually schedule your application to run on. And will let the kubelet running on that worker know that it needs to create a new pod. A new pod will then get created, and the information will, of course, be translated back so that you know your workload's actually been scheduled. So what are the benefits of Kubernetes, right? One of the main benefits is it really allows developers to feel like you have a data center on your laptop. It provides a really easy, streamlined way of being able to say, hey, I want this workload scheduled. Hey, I want this infrastructure set up. And so it really gives you all of this access and power from a more simple machine. Another benefit, as I'm sure you all know, is that a developer's environment using Kubernetes can now mirror a production environment. With containers, you're essentially saying what operating system, what additional binaries you want to actually be running on your for your workload. And so you can ensure that when your workload actually goes into production, you're going to have all the correct binaries packaged along. You're never going to have your workload, your application depending on something that doesn't exist there. Because in addition to your application, you can then say, and then this is the container image that I want my workload to actually be running in. And so you get that safety net. Kubernetes is also multi-cloud, so you don't have to be tied into a specific IaaS provider. You can be using AWS, GCP, Azure, vSphere. The list goes on and on. So it really provides that extraction so you don't get tied in. And last but not least, one of the huge benefits or maybe not last but not least, but one of the biggest things is we've really seen in the past year or two a huge community convergence around Kubernetes. One way we see this is with a lot of third-party integrations. So I don't know if no, I don't. So with Kubernetes, you get a lot of third-party integrations such as Prometheus for monitoring. You get distributed tracing with like Zipkin, you get service meshes with Linkerd and Istio. The list goes on and on. And so a lot of these third-party integrations are really putting Kubernetes as a first-class citizen for their integration partners. And so you see that you're getting all the benefits of being able to choose what integrations you want to use along with mainline Kubernetes. And so with that, we see that you get a lot of flexibility in what additional features you want added to your Kubernetes cluster. But also with Kubernetes itself, the community has really optimized for allowing you to make your Kubernetes cluster to your own specific standards and your own specific desires. There's a lot of flexibility built in. If you ever look at like the Kubernetes documentation, there's a whole slew of features, a whole slew of flags to be turning on and off features. You'll see features in alpha, beta, GA. You'll see that it's a highly developed project. And so there's so many different paths that you can take in designing a Kubernetes cluster to fit your needs. So given all of that, you can see here with this quote from Kelsey Hightower, who some of you may know, Kubernetes is a platform for building platforms. It's a better place to start. It's not the end game, right? So what we're seeing here is, Kubernetes is great. It allows you all this flexibility, but you shouldn't just stop with Kubernetes, because if you as a developer want to take on managing all of the complexity of Kubernetes, you're in for quite a challenge. I recommend, if you're really interested, to actually check out Kelsey Hightower's Kubernetes the Hard Way tutorial. And a lot of people quickly get dissuaded from wanting to stand up their own Kubernetes cluster. And so that's why we see PKS coming into the picture as one such offering of, an endgame per se. So PKS, which stands for Pivotal Container Services, is a managed Kubernetes for multiple clusters. So let's highlight two main things here. First, that it's a managed Kubernetes. So with PKS, we're actually sifting through all the flags, all the new features for your Kubernetes cluster that you could possibly care about, and really creating sane, optimal defaults for your Kubernetes. We're presenting how we think Kubernetes should be instantiated while still allowing you the flexibility, of course, to be turning on and off specific features for your needs. So you still get the flexibility, but you get it packaged to you in a much more understandable way. And secondly, another major thing about Kubernetes is it's for multiple clusters. So it's not just you have to, let's say, Kubernetes allows you to have a managed, many managed Docker containers. It takes away you having to keep track of all of those. But with Kubernetes, you could be standing up multiple clusters. Now the question becomes, of course, who's watching, who is maintaining all of these clusters? And so PKS not only is going to be giving you a managed Kubernetes, but it's going to be doing it for multiple clusters, which is something that you don't see with a lot of other Kubernetes installers. It's also really focused on day two operations. So a lot of times you'll see with other installers like kubeadm and kops, they're really focused on, maybe a good experience of deploying a Kubernetes cluster, but not so much about what happens when I want to upgrade this cluster. What about security patches? What about things that I care about when I actually have production workloads running? And so with PKS, we're really focused on these day two. How do I upgrade? How do I maintain? How do I ensure stability? And the way we do so is we use Bosh, which some of you may also know is the tool that allows us to deploy Cloud Foundry. So how exactly does Bosh help? Well, BOSH is a tool that also focuses on day two operations. It looks at being able to manage and deploy both large and small scale cloud software. And so there's a really natural fit. Kubernetes is a large scale cloud software that needs to be deployed in some capacity. And BOSH is a tool that's focused on deploying such difficult distributed systems. So another benefit of BOSH is that you get security fixes within 48 hours for your underlying OS system. So in BOSH, we have a concept of stem cells. If there's a security bug in there, within 48 hours, a patch will be released, and it's really easy and simple to be upgrading the underlying operating system. So you're getting that benefit of not having to worry about the OS on which your Kubernetes is running and and patching those security vulnerabilities. BOSH is also security aware. So what I mean by that is more and more we see there's been a shift towards security as a first class citizen, a first class thing that we really care about. You want TLS everywhere. You want, secure passwords everywhere. But with Kubernetes, as I've mentioned before, it's really flexible. There's a lot of ways you can configure your components to be talking via TLS. There's a lot of certs and keys to be managing. And so what BOSH will do, it will actually generate your certs, keys, your passwords for you and store them in a secure database called CredHub, which is another open source tool. And so this way, it's easy for you to be doing the right thing, be configuring the right certs and keys, because BOSH is really doing all of that for you. It's really generating and maintaining those certs, CAs, and keys. And lastly, with BOSH, it also monitors and resurrects virtual machines. So if we think back to that initial picture of what a Kubernetes cluster is, a Kubernetes cluster is made up of masters and workers, each of which is its own virtual machine. And so what BOSH will do is, because BOSH is the deployment tool that you're using to actually be creating all of these virtual machines, we see that if a virtual machine goes down, BOSH actually knows about it, because BOSH is what deployed it in the first place. And it will actually monitor the state of the world. It will see, hey, is all the VMs that I think I've created, do they still exist? Are they still happy? Are they still healthy? And if they're not, there's a feature called the VM Resurrector that will actually go in and resurrect that VM to make it a healthy state of the world. And last but not least, BOSH allows for reproducible deployments. So all the things we've talked about before this, it really focused on keeping your cluster alive, keeping it running, keeping it healthy. But in the worst case scenario, if your cluster does fall over and you need to redeploy it, the mechanism by which BOSH is creating these Kubernetes clusters is via a YAML file. And so it's easy to simply grab that original YAML file, redeploy it, and get the exact same cluster. You're not going to have snowflake environments. So if we take sort of starting at the bottom up, and we sort of visualize how all these components work together, we see that at the very base level, you have your core infrastructure. And from there, you deploy BOSH on top of that infrastructure to as your tool, again, for creating your Kubernetes clusters. It will then deploy PKS, which is what will actually, and then we'll watch it. And from there, you'll interact with the PKS VM to create a Kubernetes cluster. And what we see is actually happening under the hood is when you say you want to create a Kubernetes cluster to PKS, it's actually having BOSH deploy that cluster. And then BOSH will watch it again. And you'll do it for multiple clusters. What's up? Yeah, so KATE stands for Kubernetes. So it's just a cute shorthand, 8 letters between K and S in Kubernetes. Yeah. So, that being said, in this diagram, we've talked about BOSH, we've talked about Kubernetes. You might be wondering, what is this PKS, right? You've said that PKS is a managed Kubernetes. You say it uses BOSH under the hood. But what is this PKS component? Because BOSH alone isn't our offering of Pivotal Container Services. We utilize BOSH along with our packaging of this box here, which is PKS. So how does PKS actually work in conjunction with BOSH to be creating these clusters? So we'll do a brief deep dive. So if we take that PKS box and we expand it a little bit, we see here that in our PKS VM, we have an API that you're interacting with. And then we have two components sort of coupled together called the Ondemand broker and the service adapter. So when you want to do a PKS create cluster, you as an end user run that command in the CLI, targeting your PKS installation, and it goes and hits the PKS API right here. The PKS API says, okay, I've gotten information that you want to create a cluster, and we'll pass that information along to the Ondemand broker. The Ondemand broker will then actually say, okay, I see you want to create this cluster with these specifications, but I need an actual manifest. The Ondemand broker is actually an open source component that we also use for services in Cloud Foundry. And so while it knows how to interact with BOSH, it doesn't necessarily know what you want to be deploying on BOSH. So it says to the service adapter, can you generate for me a manifest that will have all of the information about the PKS, about the Kubernetes cluster that needs to be deployed? The service adapter says, yeah, passes the information back, and the Ondemand broker can then use that manifest to deploy with BOSH. So it will pass that information of the manifest along to BOSH and say, hey, I want you to deploy this Kubernetes cluster. BOSH goes ahead and deploys it, and you can do that for, again, multiple clusters. So that's a very high-level overview. I'm happy. I wasn't sure maybe what people's interest levels were. Happy to talk about anything more. Happy to whiteboard things as well. But there's a lot more resources that you can look at. There's just a resource list in general for all things PKS. There's a PKS technical architecture overview, which goes into a lot more detail. There's also a couple Slack channels I know, at least on the Pivotal Slack, for pivots who might be interested in learning more. And lastly, all the Spring 1 presentations are now up, and there's a lot on PKS, a lot on Kubernetes as well. And so I would highly recommend looking at them. And if you have specific interests, I might be able to also direct you to specific videos. And with that, I'll take the many questions that are coming up. Who wants to go first?
Is there a public version of PKS like PDubs?
Yeah, so the question was, is there a public version of PKS like PDubs? Not right now, no. Yes.
So is there, what couldn't PCF do before this that Kubernetes provides?
Yeah, so the question is, what couldn't PCF do before this that Kubernetes provides? I think the main use case really is, PCF is really focused on like specific types of applications. It's a lot harder to, let's say, take off-the-shelf third-party commercial software and deploy it as an app in PCF. It's a lot easier to take, maybe some third-party software you rely on and deploy it as a container in Kubernetes. So that's sort of the use case that PKS is really focused on, that it was a lot harder to provide in the PCF landscape. Rowan had a question, I think.
That answered most of my first question, but my other question, which might be detailed, is does PKS ship with a container networking plugin out of the box?
Yeah, so the question was, does PKS ship with a container networking plugin out of the box? Yeah, so by default, another added benefit of PKS is that it's by default bundled with NSXT, which is VMware's latest offering of a networking solution. Otherwise, you can be using Flannel as the networking plugin. There's not any other options for exchangeability yet at this point between the two. Also a plug, gave a talk at Spring One with Gaetano from VMware about PKS plus NSXT and the value add you get there. So if you're interested in exploring that, you can watch our talk as well.
So maybe related to that, so if I have my special workloads PKS and I have my normal app on classic Cloud Foundry, can they communicate easily?
So the question was, if I have an app on PCF and a workload on PKS, can they communicate? Right now, they would have to just be communicating back out via the internet and back in through a load balancer. I guess in order to do that, you would want to be deploying both PCF and PKS on the same networking stack. Theoretically, you can be doing that with NSXT because both PAS and PKS support NSXT, but because Kubernetes is still relatively young and there are still some issues just in general with security in Kubernetes, we don't recommend deploying both on the same underlying network. Okay.
So that kind of touches on my question, which is given that we have PKS, why would someone continue to use Cloud Foundry to run some of their apps?
Yeah, so the question was, given we have PKS now, why would you choose to be using PCF or Cloud Foundry? And I think that goes sort of back to the answer I just gave to Dirk, which is that PKS is still a relatively young project. Kubernetes is a relatively young project. It definitely there's not as much of a notion of tenancy in Kubernetes or PKS as there is in PCF. You're not getting a lot of the security benefits that you do in PCF, in PKS. And so PCF is really focused on the 12-factor app really having secure tenancy, and it's been proven. It's been around for a long time. And so I think it has solved those use cases really well, to the point in which it doesn't necessarily make sense to be porting everything over to PKS, where it's not providing as much of that security and sort of just, I guess, inherent, it's been proven for a very long time. Yeah.
Is PKS something you pay for if you want it, or do you get it if you have a PCF installed for free?
Yeah, so the question was, is PKS something that you pay for, or do you get it if you have a PCF for free? PKS is on a different selling plan than PCF, so you don't get the two of them together. Back there.
So for the developer who uses PKS or Kubernetes, is there any difference? Does PCF take any responsibility on top of?
Yes. So the question was, for a developer, is there any difference between PKS and Kubernetes? For the app dev, there's no difference. So really what PKS is providing is that management for your platform operator or your cluster operator. And that's the value add. It should be the same development experience for an app dev using Kubernetes or PKS. One of the goals is to provide a vanilla Kubernetes experience for the end user. Yeah. Go.
There's a little bit of security benefit in the fact that it's managed Kubernetes. So, for example, the fact that an operator can choose to upgrade the kernel and fix security vulnerabilities in the kernel, and that will take effect without the application developer knowing or caring that happened. That's a benefit to the way PKS operates, right?
Not necessarily, because in general, I think you'll see at a lot of companies, there is a distinction between cluster operators and app developers. And so your cluster operators would still need to be going and patching your underlying operating system for your masters and worker nodes. And so what the benefit really is now it's a lot easier for your cluster operators to be doing that with PKS. Than it would be if they were having to manage several different Kubernetes clusters for their application developers. You'll see in most models, at most organizations, application developers won't also be cluster operators. There'll be cluster operators who stand up the cluster and manage the cluster and then give kube configs to the application developers who can then target those clusters and deploy their workloads. Yes.
Who are the PKS competitors, and what are the similarities and differences?
Yeah, so the question was, who are the PKS competitors and what are the similarities and differences? I haven't really done a huge deep dive. I would say like maybe some of the main competitors are like for managed Kubernetes, Red Hat, or also a lot of just the IaaS like providers of like GKE, for example, or AKE, or all of the other Ks for each of the different IaaSes. I think like the pros with PKS is that with PKS, like just looking again at all the different IaaS providers like offerings, is that you're not tied to an IaaS with PKS. So like, for example, if you deploy on AKE, like what's your migration strategy from AKE to GKE? Another thing is that we are really focused on multiple clusters. So in a lot of other providers, you'll see that they're really focused on helping you manage a single cluster. And you'll see a lot of like large single clusters for a lot of application developers to use, rather than many small clusters, which have sort of the added benefits of like a little bit more security around tenancy, that you're only giving like one team, one cluster. And then lastly, I think the main thing is day two. Really, like if you ask people, if you go up to anybody using Kubernetes and you say, what's your upgrade strategy? They laugh. A lot of times the upgrade strategy is spinning up a whole new cluster and tearing down your original cluster because it's just that difficult to upgrade. And so we're really focused on that scenario of being able to take an existing cluster and upgrade it without downtime. Because right now that's not a story you hear very often.
And those upgrade challenges apply to GKE and AKE as well?
So the question was, did these upgrade challenges apply to GKE, AKE as well? I can't say yes or no off the top of my head. I would have to double check. Yes.
Angela, you were saying that some of what PKS provides is a simplified set of config, slightly opinionated about the deployment. Can you illustrate some of those decisions that PKS takes for you?
Yeah. So the question was, during the talk, I mentioned how Kubernetes can be really complex, and we provide some sort of default opinion. And if I could provide examples, yeah. So I think like maybe like one example of this is, and this goes back to like so. Maybe this is a long-winded answer, but Kubernetes provides a minor version every 3 or 4 months or so, every quarter. And each minor version, there's a pretty substantial set of changes. There are features in alpha, there are features in beta, there are features that are GA. And so managing and keeping track of all of those, for example, one thing we do is we're really hesitant to introduce alpha features and expose it to the end user, because with alpha features, you don't get a promise of backwards compatibility. So if you introduce an alpha feature in the future, you could be trying to upgrade, and there might not be an upgrade path for that feature. So that's one way that we're like slightly opinionated, is we don't really expose those things. Another other things we do is we sort of look over the latest greatest features and really decide like which ones are key to expose to an end user. So recently we've really been focused on in 1.2, I believe, or 1.1, we introduced multi-master, so having multiple masters so you don't have control plane downtime in the case of like an AZ failure or something like that. We've also been working a lot on the identity use case, and so like providing a sane way of connecting like an existing LDAP server to easily be able to be allocating clusters to different users in your LDAP server. I don't know does that answer your question? Okay, cool. Any other questions? Okay, well, I'm always happy to chat about anything more PKS. I'm pretty sure this was a whirlwind, but thank you.
Thanks a lot.